Let's define the state variable, in this case satisfied with work. And let's define the state variable value, okay? The value that represents the presence of the condition. In our case, it's going to be a 1, okay? From a display perspective, we're going to ask for the ROC curve. We're going to ask it to put in this diagonal reference line, and we're going to ask for the coordinates of the points associated with the ROC curve. That's all we have to do. I'm just going to hit OK. There's a little bit of output here, but let's not panic. The first bit of output is how many particular cases we had from a case processing perspective, how many were positive, how many indicated they were positive, how many indicated they were negative. So from a positive perspective, there was 18 positive cases, there was 51 negative cases. Okay. And here's the ROC curve, and we'll get back to the ROC curve in a moment on how to interpret this. Okay. And then what we have down here is we have a list of pairwise values for sensitivity and specificity, and along with those pairwise values we have the actual scores on the scales that were achieved, okay, by individuals. Okay, so going back to the ROC curve, how we interpret it is this, is that what we'd like to do is we'd like to make sure that we increase sensitivity. Okay, so we need a high sensitivity score. Now, from our perspective, sensitivity is going to range from 0 to 1. Okay, let's keep in mind that sensitivity represents how good we are at correctly identifying those people that have a specific condition. In other words, how good are we identifying true positive rates? Okay, so what we'd like is a high sensitivity score. That is, we would like to be able to correctly identify those that have the condition, those that are true positive. And then what we'd like to also do is, well, we actually have 1 minus specificity. Now, don't forget, specificity represents the likelihood of correctly identifying those without a condition. So if I want to be able to correctly identify those without a condition, I need to be high on the specificity scale. Okay, but another way to think about it is 1 minus specificity would mean I need to be low on the specificity scale. Yeah, sorry, I need to be high on the specificity scale, but with respect to this particular variable here, 1 minus specificity, I would like to see low 1 minus specificity scores. Okay, so actually where we'd like to be on the ROC curve is we'd like to be up in this region up here. Okay, and what we do is we follow this particular blue line. Okay, we follow this blue line around, trace it around. You can see there are all the possible combinations of 1 minus specificity scores along with sensitivity scores. And what we want to try to find is the one that maximizes both sensitivity and 1 minus specificity. Actually, the question is, what point is closest to this particular coordinate here? What point is closest to the coordinate 0, 1 on this particular blue line? Now, one way to do it is to look at this particular reference line here, this diagonal line, and to shift the diagonal line parallel in this direction, okay, until we find the point on the blue line that's closest to this particular demarcation point. I think it's pretty clear from this particular curve here that the point that's closest is this point right here. Okay, that's the point that is the least distance away from this particular coordinate. Okay, and that's the point we're interpreting. And you can actually see. Actually, let me just maybe double click on this scale and make it a little bit more accurate in relation to its values. Let's double click on this. Let's go to scale. And instead of, let's say, our major increment being 1, let's make our major increment be 0.2. Let's apply that. Okay. Let's just apply that to the scale. Okay. Is that being applied? And let's close that here. Close. Oh, for some reason it didn't apply it. Okay, let's do it again. Actually, what I'm going to do is I'm just going to double click on this. I'm going to go to scale. My minimum is 0, my maximum is 1, and my major increment, okay, is 0. My major increment is going to be 0.2. Okay, if I apply that, it doesn't seem to be applying it for me here. Yeah, okay. It obviously doesn't like that particular scale value. Okay, but let's just work off this particular chart. Okay, so what we have is this particular point here, which seems to be in around 8.2 on the sensitivity axis, and it seems to be just below 0.2. Okay, so let's keep that in mind. The 1 minus specificity value is in around 0.2 or just a little bit below it, and the sensitivity value is in around, I suppose it's in around 0.81. Okay, so we have just about 0.2 for sense specificity, and we have about 0.81 for sensitivity. Okay, so with them two values, okay, with those two values, 0.2 for specificity and about 0.8 for sensitivity, we can actually go down here now and we can actually look for those two values in the sensitivity and 1 minus specificity column. So I'm looking for sensitivity values that are in around 0.8, which are these values here, okay? And I'm looking for specificity values that are in around 0.2, okay? Which are in around here somewhere. So actually, three possible values would be these values here, okay? Actually, I think it was closer to 0.2. Well, it wasn't that close to 0.2. It wasn't 1.96. It was probably about 1.76, yeah? Or sorry, about 0.176. So actually, with a sensitivity of 0.833, and a 1 minus specificity score of 0.178, that gives us a scale value of 3.75, okay? So actually what we're saying here is this, is that anybody that scores above 3.75 on the job satisfaction scale, okay, are more than likely to have the condition, okay? In other words, be satisfied in their job. Anybody that scores less than 3.75 on the job satisfaction scale, okay, are more than likely to not have the condition, okay, and to have been correctly identified as not having the condition. In other words, correctly identified through negative values, okay. So actually, on the scale of job satisfaction, which ranges from 1 up to around 5, 3.75 is the cutoff point. It's the demarcation point. Okay guys, this was a pretty quick video in relation to how to identify a specific cutoff point associated with a psychometric scale. The important thing in being able to identify that particular point is that we have two variables, okay? That we have the scale that we're trying to find the cutoff point for, and that we have a measure of, I suppose, a true measure of true positive and true negative, yeah? In this case, we have this particular gold standard that we're benching against, yeah? In this case that we're dealing with, this is a self-reported value. Everybody was asked whether they are actually satisfied or not satisfied with work. Yes, indicating that they're satisfied. No, indicating that they're not satisfied. And then the job satisfaction is, I suppose, score is based off this particular 10 item inventory. Yeah. Okay. But ultimately, using the ROC curve, we can actually find a cutoff point for job satisfaction. So going back into my chart, okay, my histogram, okay, what I'm really saying is in around here, in around 3.75 is an appropriate cutoff point. Anybody above 3.75 are satisfied, and anybody below 3.75 are not satisfied. Okay. This is a reasonable way to actually figure out an optimum cutoff point is by looking at sensitivity and specificity values that are associated with particular psychometric scales. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope this video was in some way intuitive and helpful. Once again, thanks for watching.